Hello everyone. Today I'm diving into some core ideas in physics that help us understand the world around us. Ever wondered how a car moves? Why we feel tired after pushing something heavy? Or how a magnet can pull metal objects without touching them? All these questions tie into motion, force, and work. By the end of this lesson, you'll have a solid grasp of how these concepts affect everything from the smallest particles to massive machines. Let's dive in. First up, motion. Motion refers to the change in an object's position over time. When something moves from one place to another, it's in motion. Think of a train moving along tracks or the hands of a clock ticking away. These are all examples of motion. We can describe motion using three key terms: speed, direction, and distance. Speed is how fast something moves out there. Direction is the path it moves along, like north, south, left, or right. And distance is how far it travels. For instance, if you ride your bike to school, you're moving forward at a certain speed. That's motion. Now let's look at the types of motion. There's linear motion, like a car on a straight road, so rotational motion, like a spinning wheel, and oscillatory motion, like a swing moving back and forth. Objects can experience more than one type of motion simultaneously. Take a car, for example. Its wheels experience both linear and rotational motion. Next, let's talk about force. Force is a push or pull applied to an object. It's what makes objects move, stop, or change direction. Force is measured in newtons, and it has both magnitude and direction. Think about pushing a door open, pulling a drawer, or lifting a box. These are all examples of force in action. There are also different types of forces. Gravitational force pulls objects toward the Earth, keeping us grounded. Frictional force resists motion when two surfaces touch, like when brakes stop a bike. Magnetic force is what a magnet uses to attract or repel objects, like pulling a metal nail. And applied force is any push or pull you apply directly, like pushing a shopping cart. For example, when you push a book across a table, you're using applied force, and friction is resisting the book's movement. Finally, let's talk about work. In physics, work is done when a force causes an object to move in the direction of the force. Work is calculated as force times distance and is measured in joules. If you push a box and it moves, you've done work. But if you push a wall and it doesn't move, there's no work done because there's no movement. For instance, if you lift a heavy book up to a shelf, you're doing work against gravity. Let's quickly recap. Motion is the change in position of an object. Force is a push or pull that causes movement or a change in direction. And work is done when force causes movement in the direction of the force. These concepts are interconnected. Motion happens because of force, and work is done when force causes movement. Now that we understand the basics of motion, force, and work, we can see how these principles apply in our everyday lives. Next time you push something heavy or see an object moving, think about the forces and the work involved. Thanks for watching, and keep observing the world around you with these new ideas in mind.